vehicles since 1970. Their purpose is to collect fuel vapours from the fuel tank, and in earlier vehicles the carburetor float bowl, store them, and at the correct time move them to the intake manifold for combustion. Evap systems have changed over the years from simple float bowl and fuel tank vacuum operated types to fully sealed OBD2 monitored and ECM controlled systems. Most current systems utilise the following components: fuel tank, fuel cap with pressure and relief valve, vapour separator, vapour lines, charcoal or evap canister, purge solenoid valve and purge lines. Fuel filler caps are non-venting and have a positive and negative pressure relief valve built in. Under normal conditions, the valve is closed. When extreme low or high pressure is present, the relief valve opens to prevent the tank from collapsing or ballooning. Once the pressure has been relieved, the valve closes. The vehicle's fuel tank is a sealed unit and has been designed to prevent vapours escaping to the atmosphere. The fuel tank may have a separate chamber at the top to allow for expansion and contraction of the fuel vapour due to temperature changes. These vapours are collected and stored in a canister filled with activated charcoal, where they are held until purged to the vehicle intake manifold. Fuel vapours inside the fuel tank are vented at the top of the fuel tank through a vapour separator. This device collects any droplets of fuel and returns them to the tank. Only vapour moves through the separator to the canister. The contents of the carbon or charcoal canister is in the form of activated carbon granules. The properties of this material allow hydrocarbon vapour to be suspended within the granules. The canister purge valve is normally in the closed position, holding evaporative emissions in the canister. Early evap systems were not controlled by the ECM, but relied on a vacuum-controlled purge port, a vacuum check valve, and a thermo-vacuum valve, or TVV. The TVV was used to prevent canister purge on a cold engine. When the throttle plate was opened enough to uncover the purge vacuum port, a small amount of vacuum opened the check valve, which was located on the top of the carbon canister. This allowed evap vapours to flow to the intake manifold through a large separate pipe. The vacuum check valve is also used to keep the system sealed when the engine is not running. This early type of system was not efficient. The combustion mixtures changed in response to the amount of vapour exiting the charcoal canister. As there was no electronic feedback to trim the air-fuel ratios, vehicles suffered from poor performance and emission issues during purge. To achieve more control over canister purging, evap operation is now handled by the vehicle's ECM. These systems use a purge solenoid valve that is duty cycle controlled. The purge valve is only opened when the ECM determines the engine is at the correct operating temperature and in closed loop mode. The engine can then utilise the enriched fuel mixture, this time without affecting performance or emissions. These systems allow precise control of vapour volume and flow, so when purging, drivability is not altered. Evap systems should be tested regularly for leaks and correct operation. A system with faults can cause drivability issues and increased emission levels. To check for leaks or decay in the evap system, a leak or smoke tester should be used. Introduce smoke into the system from the tank side of the purge valve and inspect all vapour lines to the fuel tank. Be sure to inspect around the fuel cap for correct sealing. Leaks in the evap system not only allow vapours to escape to the atmosphere, but can also allow unmetered air to enter the intake manifold, causing poor engine performance, and DTCs may be set. Connect a hand-operated vacuum pump to the outlet of the canister and operate. Use a clear looped hose and observe the result. If any liquid appears in the hose, then the canister is fuel saturated and will require replacement. Most systems use the ECM to control the operation of the canister purge control solenoid. On this system, battery voltage is delivered to the evap solenoid via an ignition relay. A low reference is supplied via a low side driver within the engine control module. When the ECM decides conditions are ideal for a canister purge, the ECM pulse width modulates the low side driver. This completes the circuit and the purge solenoid is opened. To test the control system, it's necessary to use either a scan tool or oscilloscope. On the oscilloscope, with the engine running, monitor O2 sensor data and operate the purge control solenoid. The O2 sensor should display a rich mixture and the engine will run roughly. Stop the engine and connect the hand vacuum pump to the purge solenoid. Apply vacuum and using the scan tool, operate the purge solenoid again. There should now be airflow through the valve indicated by a drop on the gauge. To check the ECM control, it's best to use an oscilloscope. Back probe the purge solenoid and turn the ignition on. Battery voltage should be evident on both sides of the solenoid. This confirms there is continuity through the windings. Operate the purge function on the scan tool. Monitor the oscilloscope again and you should see a square wave signal on one side of the solenoid valve. This has just proved the control circuit from the ECM is okay. It's imperative that these systems are correctly maintained to conform with current emission regulations. As always, having a good understanding of system operation makes diagnosis much easier. Thanks for watching.